Boom! Yes, folks, Hume again. How are you going? So welcome to yet another in our series of videos where we're dealing with the circle. Alright? In this video, we will discuss two more properties of circles. These are properties that directly relate to what we refer to as the cyclic quadrilateral. Alright? What is a cyclic quadrilateral? A cyclic quadrilateral is simply a quadrilateral whose vertices lie on the circumference of one circle. Alright? Another name for a cyclic quadrilateral is what we refer to as an inscribed quadrilateral, meaning simply the quadrilateral is inscribed within the circle. It means that the quadrilateral lies entirely within the circle, and each vertex, or all four vertices, lie on the circumference of the circle. So if we want to say that in more colloquial language, we just simply say that a cyclic quadrilateral is a four-sided figure where all four corners are on the circle, where all four corners touch the circle, where all four corners lie on the circle, etc., etc. The point is that I don't want people to get so caught up in the language that they lose the meaning. Alright? If you are one of those people who don't like too much of a big vocabulary and thing, and you want to break it down in colloquial language, that is also welcome. Nothing wrong with that. I will try to do that wherever is possible to promote the understanding. Alright, so Theorem 4. My Theorem 4 says, and again, this is one of the regular circle theorems, but I just put it in position number 4 for my own teaching purposes. Alright, so Theorem 4 says that, and where is the syllabus? Right. So I'm going to quote from the syllabus again, and the syllabus says that the opposite angles of a cyclic quadrilateral are supplementary. Right, some more big vocabulary. What do we mean when we say that two angles are supplementary? Two angles are supplementary if they add up to 180 degrees. Alright? So 180 degrees and 60 degrees, supplementary. 120 degrees and 60 degrees, I'm not sure if that's what I said, but okay. 120 degrees and 60 degrees, supplementary. 130 degrees and 50 degrees, supplementary. 95 degrees and 85 degrees, supplementary. Alright? 100 degrees and 80 degrees are supplementary. In other words, the supplement of 100 degrees is 80 degrees. The supplement of 116 degrees is 64 degrees, etc., etc., etc. Alright? Two angles are supplementary if they add up to 180 degrees. And just as an item of further knowledge, we also have what we refer to as complementary angles, where the two angles add up to 90 degrees. So you need to be extremely careful. You need to be very clear on the difference between complementary angles, angles that complement each other, so to speak, which is they add up to 90 degrees, versus supplementary angles, angles which supplement each other, that is, they add up to 180 degrees. So, examples of complementary angles, 60 degrees and 30 degrees. Sorry, complementary angles. Examples of complementary angles, 60 degrees and 30 degrees. Complementary angles, 45 degrees and 45 degrees. Complementary angles, 57 degrees and 33 degrees. Complementary angles, etc., etc., etc. So in other words, the complement of 57 degrees is 33 degrees. The complement of 62 degrees is 28 degrees. The complement of 47 degrees is 43 degrees, etc., etc. So you get a little extra there, right? Supplementary angles, the two angles add up to 180. Complementary angles, the two angles add up to 90, right? I am not sure if there's a word for two angles adding up to 360. I will have to go and do some digging where that is concerned. All right, so Theorem 4, my Theorem 4, well, it is also in position 4 in the syllabus, says that the opposite angles of a cyclic quadrilateral are supplementary. Cool. So we have discussed in this video what is a cyclic quadrilateral. We have discussed what it means when we say that two angles are supplementary. Alright? These are little things that you have to know because one, you'll be called upon to explain certain things in the context of a question in section 2 of the C-Sec Mathematics syllabus. And two, they might throw the question at you using the mathematical vocabulary. And you as a student will be expected to know what they mean and then give the answer based on that particular knowledge. Excuse me. So we have two circles here, identical circles, and I tried my best to reproduce the cyclic quadrilateral, and you'll see why we did that in a little bit. So let us label the points with some letters. So let me say this is A, this is B, this is C, and that's D. Alright? So what Theorem 4 says is that the opposite angles of a cyclic quadrilateral are supplementary. Based on the previous discussion, we know that this is a cyclic quadrilateral. So in other words, in the context of a question, you will be called upon in many instances to recognize a cyclic quadrilateral. That is one of the things that they don't usually spell out. They wouldn't. It is hardly likely that you'll see a question where they say ABCD is a cyclic quadrilateral. Most especially if they give you a diagram. If you get a diagram, they expect you now to look at the diagram and notice that all four vertices are on the circumference, then boom, you have a cyclic quadrilateral. And if you have a cyclic quadrilateral, it means that this angle here and this angle here are supplementary. It means that this angle here and this angle here are also supplementary. So in other words, angle A, and I'm using the notation now, angle A plus angle C is equal to 180 degrees. Alright? Should I do that, boy? Listen, we actually talking, so let me try to minimize the complicated handwriting. Alright? Let me make life simple now. Alright? So we're saying that, let me say angle A, just for the sake of argument. Angle A plus angle C equal 180 degrees, 180 degrees, and by the same token, angle D plus angle B equal the same 180 degrees. Right? If you just want to use the letters alone, you could simply say that A plus C is equal to 180. You could also say that D plus B is equal to 180. So in other words, this angle here and this angle here are supplementary. This angle here and this angle here are supplementary. And if I could use a slightly different notation for the angles now, again, all of this is extra stuff, but if you're paying attention to the video, you'll pick up stuff in case you need to pick it up. Alright? Let us use a slightly different notation. Angle A. We could either refer to it as angle DAB or angle BAD. My personal preference is to go anti-clockwise. It doesn't really matter. What matters is that the angle, the letter where the angle occurs is in the middle. So I could say that angle DAB plus angle BCD is equal to 180 degrees. And by the same token, I can say that angle CDA plus angle ABC, yeah, plus angle ABC is equal to 180 degrees. So in other words, what this allows you to do is that if you know any one of these angles, let us say for example you knew that this angle here was 30 degrees. If this angle is 30 degrees, then it means that by virtue of this particular property that we're discussing, that this angle here would be 150 degrees, which is 180 minus 30. Let us say, for the sake of argument, that this angle here is 92 degrees. What it means, what this theorem means, is that if this angle is 92 degrees, then we could find this angle by invoking this particular theorem, where the opposite angles of a cyclic quadrilateral are equal, and we say therefore that this angle will be 180 minus this angle. In this case, if we agree that this angle is 92 degrees, then this angle D here will be 180 minus 92, which is 88 degrees. Alright, so that theorem is pretty simple, straightforward. This is usually one of the theorems that students latch on to very quickly. Very, very quickly. Simply because cyclic quadrilateral, no set of big set of stress, no set of calculation in that. That is just about recognizing. In fact, almost all of circle theorem depends upon observation. And as I tell my students all the time, observation is the first law of the mathematical jungle. You have to observe, you have to look, you have to look, you have to look, and you have to see. Alright? You have to look and then you have to see. And then when you see, you draw upon your knowledge to solve whatever situation that you happen to be in at the time. Alright, so that is theorem 4, and we're going to use this circle here to discuss theorem 5. So let us now invoke the eraser. Alright? Right? So we're going to rub off here now. Right. Forget the circle for the time being. We're going to use the same lettering, right? A. Notice I put in the letters kind of further out this time, and you'll see the reason for that very shortly. So theorem 5, my theorem 5 says that the exterior angle of a cyclic quadrilateral is equal to the interior opposite angle. Right? Let me say that again. The exterior angle of a cyclic quadrilateral is equal to the interior opposite angle, or the opposite interior angle. How I would put it, I would say the opposite interior angle. It makes more sense from a linguistic standpoint. So I would say that the exterior angle, and I'll need to make the change here, the exterior angle of a cyclic quadrilateral is equal to the opposite interior angle. Alright? So you have the exterior angle, and then you have the opposite interior angle. So let us go to our good friend over here and make some sense out of this. Alright? So, what is the exterior angle of a quadrilateral? We could clear the board and, no, I wouldn't clear the board. I feel I might need a circle again. If we have a quadrilateral, some random quadrilateral, right? This is the interior angle, this is the interior angle, this is the interior angle. This too is the interior angle. So in other words, the interior angles are the angles formed at each vertex of this quadrilateral. The exterior angles are formed by just extending each side. So if you extend this side, you get an exterior angle here. Right? And if you extend this side, you get an exterior angle here. And if you extend this side, you get an exterior angle here. And if you extend this side, you get an exterior angle here. Now, of course, we could play the same game in a slightly different way. Because if I extend this line like this side like this, then the new exterior angle formed by this extension would be here. Alright? In fact, no. Here what? Let me draw the same quadrilateral just to make the point. If I try to put all that on one quadrilateral, that'll make things a little too confusing. Alright, so let me try and replicate now. We have one here, this looking kind of 90 degrees-ish here. We went so, and then we came like this. Alright? Right, so looking like a slightly larger version of the same quadrilateral. Alright? So we came like this, and we came like this, and we came like this. This was a line was a little shorter. And we come down like this. Alright, looking same-ish. Same-ish. Right? Now, we could play the same game in a slightly different way. So I could extend, instead of extending at this point here, I could extend here. In which case, the exterior angle would now be here. Instead of extending here at this point, I could extend down here. In which case, the exterior angle would be here. Instead of extending here at this point, I could extend here. In which case, this would be a new exterior angle. And instead of extending up there, I could extend across here. In which case, the exterior angle would be here. Notice that for the two shapes that we drew, depending on how we extend the line, this angle is the vertically opposite angle to this one. This angle is the vertically opposite angle to this one. This angle is the vertically opposite angle to this one. And this angle is vertically opposite to this angle. We're now going to discuss what are vertically opposite angles. That we will cover in a separate video and a slightly separate topic, right? Angles and parallel lines and whatnot. Alright, so you get the point where they talk about interior angles. The interior angles would be the same, right? The interior angles don't really change. The interior angles don't change. The exterior angles, the particular exterior angles that you're using would depend on which extension you make use of. So if we extend up here at this point, this would be the exterior angle created by that extension. If we extend this side like that, then this would be the exterior angle created, etc., etc., etc. Alright? So now we're going to apply this little bit of knowledge here to our good friend over here, where we're going to discuss the Theorem 5, which says, and we're quoting again, it says that the exterior angle of a cyclic quadrilateral is equal to the opposite interior angle. So what we do is, and this is where in some of the questions you will actually see the line extensions, or you might have to actually draw the line extensions yourself. So let us start with our good friend here. If we extend this line like this, right? You see, I knew I would have needed that quadrilateral. You see, good to follow your intuition, you know. If we extend there, then what this theorem is saying is that this exterior angle is equal to the opposite interior angle. What is the opposite interior angle? The opposite interior angle is the interior angle opposite to this point A. The interior angle opposite to this point A is this angle C. So based on that theorem, this angle here is equal to this angle here. And by the same token, if we do this, and we extend this line out like that, right? What the theorem is saying is that, make sure the signal coming in. Hello, right here, these electronic gadgets, you have to check them out, right? What the theorem is saying is that this angle here is equal to the opposite interior angle. The opposite interior angle would be this guy here, right? The syllabus said interior opposite. Nah, man, that doesn't make any sense. Opposite interior angle is what we're saying. And if we extend this line, let me say, if we extend this line here, like this, then what the theorem is saying is that this opposite angle here is equal to the interior opposite angle, which would be this angle here. Excuse. So let me use some lettering. Let me call this angle X. This also here will be angle X, right? Let me call this angle Y. This angle here would also be angle Y. Let me call this angle Z. Then this angle here would also be angle Z. And then if we extend, where we need to extend now? If we extend out like this exterior angle, let me call this one A, WXYZ, let me call this one W. This one is W. Then that would be equal to the opposite interior angle, opposite interior. This here would be angle W. Alright? And that is basically it. That is all there is to this particular theory. So let us do the same thing on this one where we're going to use the other extensions. So if we take this one and we extend the line at the point E, we extend the line here. Alright? We're still at the point E here, right? What it means is that, let me go A, B, C, and D over here now. This angle, let me call it angle A. Opposite interior angle, opposite interior angle. This angle here would be angle A. Alright? Actually, no. I need to use the same lettering. And the reason why I could use the same lettering is that it will allow you to observe further and see some things. So let me go with the X, W, X, Y, Z still. That's angle X, right? If we extend, in this case, we extend in so now. We're going up. If we extend like this, then let me see. This angle here, exterior, will be equal to interior opposite. Alright? So this will be angle W, and this here would also be angle W. Right? Need to get rid of this D. Confusing matters there, man. D. What is your scene with you? Don't worry, we didn't know we had to come back here at the point in time when I put it there. So that is how it does be sometimes, you know. Sometimes you do something and it doesn't be sure, it doesn't be aware that you have to come back. But we come back. Right. And if we extend, let me see how we extend it now. We extend, so we're doing the opposite now, right? So in this case we go in so. So if in this case we extend it like this now, right? It means then that this opposite, this exterior angle of the cyclic quadrilateral would be equal to this opposite interior angle here. So this is the same angle Y. This is the same angle Y here. And by the same token, if we extend here, we take this and we go up. We go up. Right? We extend. Then this exterior angle of the cyclic quadrilateral, this will be the angle Z. Ooh. Yeah, we're trying to make the thing look properly now. Yes, folks. Hume again. How are you doing? Papa, yeah. So this is the second video in our series where we're discussing circle theorem. Alright? You see why it's good to take off your devices when you're recording? There's other videos there. We're too far inside this video. I'm not even going back. Alright? All I gotta take it just so. Right? So this one will be what? This interior opposite angle, sorry, this exterior angle will be equal to this interior opposite angle. Alright, so this is the angle Z here. this will be the same angle Z here. Now, what I want you to do is to look at those two diagrams and you'll notice certain things. You'll notice, for example, that this x here and this x here are equal. It makes sense because if it's the same point and you extend here, then the angle here will be vertically opposite to this x here. And we know from other work that vertically opposite angles are equal. But as I said before, that's a slightly different discussion. All right? So in other words, you need to be aware of your theory with respect to angles and lines, because that will be taken for granted by the time you get the circle theorem. So in other words, alternate angles, what's the other thing? Is alternate angles, corresponding angles. You need to be aware of alternate angles. You need to be aware of corresponding angles. You need to be aware of vertically opposite angles. If you don't have that down, by the time you get to here in question 9, you could find yourself in trouble. All right? So, as is almost always the case in the section 2 questions, you realize that there are certain things that you had to know from before to get to section 2. If you're going through this video and you realize, but wait, he's talking about vertically opposite angles and I don't know what that means, well then all it means is you have to go back and check it out. Hopefully by the time you see this video, I will have a video up on that. Alright? But we will cross that bridge when we get to it. Alright? So you need to be aware of your angles, lines and angles, parallel lines, etc., etc., etc. Alright? Same thing. This Z here. No? What are we supposed to have? Right. This Z here is equal to this Z over here. Right? This Z here would be right, so the exterior angles, remember, at any vertex, there are two ways in which we could extend the line. We could extend out like this, or we could extend out like this. So on this circle, we extend it across here. And on this circle, we extend it up here. So this Z here, this external Z here, will be the same as this external Z here, vertically opposite angles. This external W will be the same as this external W, vertically opposite angles. This external Y will be the same as this external Y, vertically opposite angles. And as we just discussed, this external X here will be the same as this external X here, vertically opposite angles. And that is what it is. Theorem 4 and Theorem 5. So to cap the video off, let me just read the theorems again. You would have just gone through with me a little discussion using live circles, so to speak, of the two theorems. The next step, of course, is your practice. And that is where the thing gets nice. Alright, because some people will catch it faster than others. But the initial speed at which you catch it is not the important thing. The important thing is that you start, and more importantly, that you continue. And as you continue, you will find yourself getting better and better. So Theorem 4. The opposite angles of a cyclic quadrilateral are supplementary. We discussed what supplementary means. We discussed the opposite angles. Boom. Theorem 5. The exterior angle of a cyclic quadrilateral is equal to the opposite interior angle. And that's it. So we're making our way. We have a few more to go before we finish all the circle theorems that the syllabus actually mentions. Alright, so as always, stay tuned, stick around, come back, and when you come in, bring somebody with you. Alright? Boom. Whew. Yeah, boy. Pressure.